Very good morning, students. In this lecture, we are going to discuss about the electrical installation. First, we will discuss about the fuse unit. Okay. So, we already discussed about the fuse. Okay. Now we will discuss about the MCB, ELCB. Okay. Other apparatus which are in the electrical installation. So here we are having the. So we discuss about the electrical installation. So in the electrical installation, nothing but the apparatus used for the switching, controlling, protecting, and electrical circuits and equipments known as the switchgear equipment. Okay, so the apparatus which are used for the switching, controlling, and protecting the electrical circuits, that's called the switchgear equipment. Okay, so electrical installation is nothing but so the units so which are using for the uh, if the electrical apparatus as there, so before using, okay, so what are the equipments we are needing, okay, that we have to install for proper usage and protection and connection. Okay, so protection of the equipment and what are the connections of the input. Okay, so supply connections, how we are supplying this input to the equipment. Okay, so either it may be apparated, maybe small or big. Okay, so which are the equipments we need for proper connection, proper operation, so and protective of the equipment, what are the devices we need, what are the equipment we need. Okay, that's it. So first in that we are going to talk about the switch gear equipment. So switch gear equipment is nothing but which are used for switching, controlling, and protecting the electrical circuits. Okay, so in that the switch gear term encompasses the wide range of products like circuit breakers, switches, and switch fuse unit, off-load isolator, HRC fuses, contacts, and earth leakage circuit breakers. That is called as ELCBs. Okay, and that. So in the switch gear, essentially, so consisting of the that is the switches, fuse, isolators, circuit breaker, relays, control panels, lightning arresters, current transformer, potential transformer, and various associated equipment. Okay, so first here we'll talk about the what is meant by switches. Okay, so switches which are used for the on off purpose. Okay, someone use this, these are the switches we are using for the on off purpose, right? So on and off purpose which are using, okay, that is the fuse. Okay, switch. Okay, switch was used in on off purpose, that is the switch. So if higher one, okay, the having the higher rating of the, okay, so domestic will having the 3 amperes 2 amperes fuse. Okay, 2 ampere switches, 5 amperes switches, 16 amperes switches, sometimes 20 ampere switches also there. Okay, so based upon the equipment. Okay, so for smaller equipment, we are using the 2 ampere switch. For higher equipment, we are using 10 amperes, 20 amperes, 16 amperes switches also there, right? So based upon that, so we're placing the here. So based upon equipment ratings, we are using the either fuse or so based upon the domestic rating. Okay, so kilowatts. Okay, now how much kilowatts we have in connections. So that is the electrical house. Okay, so in house, so which are the operators we have. Okay, is that having operators, will having the number of operators. Okay, for in one room, so if it 800 watts, okay, total equipments, okay, whatever you're using the equipment, if 800 watts is there, so we are using for one fuse. Okay, so if one room is having equipments, that is the total wattage is that is a 800 watts, then we are going to using the one fuse. Okay, so based on that, for each, so based upon that we are using the fuses. If it rating is higher, okay, so whatever with the wattage rating is higher, then we are going for the equipments for better protection, we are going for the MCBs. So MCB is the miniature circuit breaker which automatically switches off the electrical circuit during the abnormal condition. Under normal conditions, it will act as a switch. Okay. So in here, we'll talk about the ELCB. So ELCB is the what we'll talk. So ELCB circuit breaker is a voltage detective device. Okay, so earth leakage voltage detector. So here, so what before talking about the ELCB, so first we'll talk about the what we have. So phase neutral we have, right? So in the domestic we'll having the one phase wire, another is a neutral wire will be there, right? Two wires will be there, and another will having the ground. Okay, so phase neutral ground will be there. Okay, suppose if you take the here we have, so here we are having the, so 3 point socket if you take it. So here is the one is the phase, another is the neutral, this is the ground. Okay, so in, so why we are using the ground? Okay, so why we are using the ground means here, suppose if they take the example as an iron box. Okay, so we'll take the iron box as the example. So in the iron box, okay, so what we'll have, so we have the phase wire and neutral wire be there. Okay, so due to that, so any leakage current, okay, so any leakage current which will flow through the this body. Okay, so if while operating this iron box, what will happen, some leakage current will flow through the this body also, right? So at that time what will happen, so who are operating this iron box, okay, well the, so he will get short. Okay, if leakage current is high, so we'll get the shock, because so leakage current, so in our human body, so 0.3 up to if the current is a 0.5 milliamperes get, so we'll get the shock. Okay, so at that time if the leakage current is high, so what will happen, will get the shock. So for that protection, so this neutral, so phase neutral, right? So this earth one, so earth is connected to the circuit. Okay, so that will be connected to the body of the iron box. Okay, so from that one we'll take that we'll having the three pins. Okay, phase neutral and earth one. Okay, so phase will indicate the red wire and neutral indicate the black or blue wire some case. So that is a green wire indicating with the earth wire. Okay, so from that one, so if will only if having the three wires, then we can protect it ourselves. Okay, not only the iron box, in the in DC missions also. Okay, suppose if the turning machine is there, okay, or lathe machine is there, so what will happen, so if the lathe machine is currently working, okay, so while operating that, so we have to touch the equipment for different conditions. Okay, so movement of the object, placing the objective. Okay, at that time what will happen, so if leakage current is flowing throughout the body of the equipment, okay, machine, so then we'll get the shock. Okay, so for this purpose we need to protect that, so how much current is flowing through that body. Okay, that will be, if okay, that will not happen, so we have to using the earth leakage circuit breaker. Okay, so the earth leakage circuit breaker, one kind of the safety device used to installing an electrical device with high earthing impedance and avoid shock. Okay, so it will avoid the shock. So these devices identify small voltage of the electrical device. So metal enclosures, that is a metal enclosure which are there. Okay, so danger high voltages are identified. Okay, so the main purpose of the earth leakage circuit stop the damage of the human, okay, damage to the human and animal due to the electrical shock. So while operating equipment, so while we'll get some cases where the touching the body of the equipment, so we'll get the shock. So if we get the shock, we'll get the shock, will damage, right? So will severe injuries will take place. So at that time we have to protect ourselves. Okay. So for that one we are using that is the earth leakage circuit breaker. Okay. So this earth leakage circuit breaker, what you do? So whenever the leakage current will flows through that, or so that if that happen, so what will do? So this earth leakage circuit breaker open the switches. Okay. So that will be not flows the current through that equipment. So at that time, so it will be tripped off. So next we'll having the MCCB, okay, modeled case circuit breaker. Okay, so another type of electrical protection device, okay, that commonly used when load current exceeds the capability of a miniature circuit breaker. That is, whatever we are in a circuit breaker, that is a miniature circuit breaker. Okay, so above that values, okay, it does not hold that current. Okay, at that time we are going to using for the MCCB. Okay, so modeled case circuit breaker. So this is also same operation, but the current rating, okay, the capacity of the current rating, that will be different. So this MCCB is protected from the different faults. Okay, so what will happen in the, if using the MCB, okay, that is a miniature circuit breaker, what we do? So if the fault comes, so it will be tripped off. Okay, so whatever the fault comes, it will be tripped off the circuit. But if the higher range of current, okay, so this MCB is having the 30 ampere, 60 ampere. If higher current is appear, okay, so if the any workshop, it will having the different motors will use. Okay, at that time all the motors are switched on. Okay, so suddenly higher due to the short circuit of the lines, so what will happen? We'll get the higher current. So at that time we have to protect the equipment. So that will be done by the MCCB. Okay, so it will be protect the equipment from the overload and current about the rated values. Okay, so here that will be same operation as like MCB, but there we having some above rated current values. So we can see the MCB's available current ratings are range from low such as a 15 amperes to industrial rating such as a 2500 amperes. Okay, so low to high applications we can use. So we'll next talk about the wires and cables. Okay, so what are the wires and what is meant by cable? Okay, so wire is nothing but a conductor without insulation known as a bare conductor is known as a wire. Okay, so if only having the conductor, that is called as a wire. Okay, so here a cable, a wire or conductor covered with some insulation is known as a cable. Okay, so it's covered with the insulation. Okay, so if it plastic, okay, so some cases the PVC, right? So presently they're using the PVC. So that is the called as the cable. Okay, so cable classification. Okay, so we have the classifications of the cables. So first we are having the according to conductor of material. Okay, so according to the conductor of material, we are having the copper conductor, aluminum conductor. Okay, so based upon the material, so which type of material using, so based on that, copper conductor, aluminum conductor we have. Okay, next according to the number of cores. Okay, so according to number of cores, nothing but if how many number of conductors will have. Okay, that if one core, one conductor means one core. Okay, that is a single core cable card. Okay, so here is the cable having the insulation. Okay, so here is having the some protective element. So protect the this conductor will have the, there is a around that. So we are insulation, cotton tape, cotton brand compound. Okay, and that the another insulation PVC cable around that. Okay, so here is the double core. So in the double core cable you have the two conductors. Okay, so insulation for different protection. Okay, so this is the three core cables. So we can say 1, 2, 3 core cables are there. Okay, so here that will protection. Okay, so each wire protected itself. Okay, so that is what, so if three wire is there, so three wires, if the short circuit, what will happen? Okay, so two it, three wires if having that. Okay, in three core cable, while having, so three wire if short circuited, so sir it will be short circuited or not, so it will be each are insulated with the insulation. Okay, so each are insulated from one to other. Okay, so in mean places that will place with the insulation material. Okay, both three, if the three conductors are there, all are the insulator from each other. Okay, so what are the, so we can see the multi-core cable. Okay, if the more number of conductors are there, okay, then it's called as a, so single core, double core, then other is a multi-core. Okay, so as a multi-core is it for the, so ranges. Okay, for the voltage range, take the, so 6.6 kilo. Okay, 6.6 kilovolts, nothing but 6,600. Okay, 6,600 voltage. Okay, so it will consist either circular core or shaped core. Okay, circular cores which are rounded one, so shaped core which are having the this like this. Okay, in the triangular way. So it is core is made up of the tinned standard copper or aluminum. Okay, so tinned standard, okay, standard copper. So are impregnate paper. So insulation building impregnate paper layers are used for the insulation building. So here in between that, okay, so here we are seeing, right. So this is the insulation paper in between there. Okay. So here advantages. We'll take the advantages. So here is a paper. So paper belts are provided with the, around the insulation. That is the around that. So each insulation, the paper is insulated. That impregnate paper will use. Okay, so here's the advantage. If you take the single core cable, can use it for the replacement of group of single core. Okay, so a, so what is the main advantage? That is the single core compared to the multi core. That is, so here if the single core, we have to use the number of phases. For three phase we have to use the three phase four wires or three phase three wires. at that time if using only one wire, okay, one cable, okay, in that will hang the phases, okay, that will be very okay. So the place which are used place also we can save, okay. So that is the advantage. So cost of installation, okay, the cost of installation is low when compared to the single core cable. So according to the voltage, okay, the cables are classified. So based upon the here the voltage is up to the 1 kV. Okay, so here low voltage that is called below 1000 volts, that is to 1 kV. Okay, 1 kV, 1 kilovolt. Okay, so 1 kilovolts, it consists of the one circular core. Okay, so it consists of the one circular core. Its core is made up of the tin standard copper or aluminum. So impregnate papers. Okay, so each lead sheath. Okay, lead sheath is provided around the insulation. Okay, so around the insulation, so we'll having the, if the conductor have, so if the single core cable, so around that we'll having the lead sheath. Okay, so is the better moisture. So if the moisture around the cable, okay, that will be insulated. Okay, so jute and is also provided the lead sheet is serving as avoid corrosion. Okay, so jute is provided around the lead sheet. Okay, if the lead sheet, then you will place the around that, so jute is placed. Okay, so here's the advantage of single core cable. So it is very simple in construction. Electrostatic stresses are the very small. So electrostatic stresses, okay, we'll talk about the simple is very construct. Okay, simple in construct. Next we'll have the electrostatic stresses are developed very small. That is whatever the current around it. Here, if any conductors are there, okay, so around there will having a small amount of current will be flows. Okay, so at that time the electrical stresses, okay, due to the electrical stress also small current leakage current flow, that is also very less compared to here. So large conductor cross section is all. That is a if single core. So large conductor cross section. That is a only conductor cross section will be there. So here we can see, okay, 11 kV. So high voltage cable having the 11 kV. Super tension cables, that is a 11 kV to 33 kV. Okay, extra voltage cables EHT. Okay, so that is a 33 kV to 132 kV lines. Okay, so extra super tension voltage cable, that is a beyond 132 kV line. Okay, so mainly for in India, so we are only using the 66 kV. Okay, so below 66 kV only we are using the cables. So for above we are going for the overhead line systems. So you can see the single core cable for low voltage application. Here is the conductor. Okay, so this is the conductor. So and here is the, we are having the, here is the metal core and the insulation and having the metallic sheet and we are having the jute. Okay, so next according to the insulation, okay, so according to the insulation we are having the classification, that is a vulcanized Indian rubber. Okay, so vulcanized Indian rubber cables, so it will consist of the copper conductor, vulcanized rubber insulation. Okay, so it is used in casing and capping. Okay, so use it in the casing and capping. So that is really conduit wiring. Okay, so in the house wiring also different systems are there. Okay, so casing, capping, conduit systems, plate wiring, okay, surface wiring. Okay, that is a different types. So the voltage rating, okay, so voltage rating, that is the 250 volts and 600 volts available. Okay, so here we can see if the single core, if the VR insulation, we are having the only one wire that is called as a single core conductor. Okay, so we are having the 7 strands. Is only without having the one conductor, having 7 strands. Okay, they sometimes will like combine with the different strands. Okay, so it will having the 7 strands. Okay, so each strands is capable of the carries the 6 amperes of current. Okay, next one is the tough rubber sheet cables. Okay, so these are used for the CTS of electrical CTS of the system. Okay, and these are cables are the available in single core, twin core, and 3 core. So twin is nothing but double core. 3 core is the 3 core. Sorry. Okay, so CTS cable consists of the VIR insulation. Okay, vulcanized India rubber insulation over the conductor with an outer protective cover. Okay, so tough rubber will be there around the conductor. Okay, okay, you can see here. So we can observe here is the conductor we are having. Okay, so here having the conductor and inner insulation and tough rubber insulations will be there. Okay, and we can see. Okay, so if this strand, this is for the single strand. Okay, we'll having the multi-strand cable that will having the same insulation different. Okay, so next we'll having the PVC cable. Okay, so general which are using now, that is a polyvinyl chloride cable. Okay, so that is the insulation with the PVC. So it's consist of the copper conductor polyvinyl chloride insulation around that. So gets affected by, okay, it's affected by the temperature, therefore it's not suitable for heating application. Okay, it's for only for where interior applications only. Okay, so higher for outside of that. Okay, only if using domestic applications only can use. Okay, where high temperature is there we cannot use for out of that. Okay, so he used it in casing and capping. Okay, and cleat wiring and conduit wiring. So available in the range of the 250 volts, 600 volts. So we'll have the we can put domestic applications like 250 volts and 600 for in case of 3-phase application. Okay, next we'll having the lead sheet. Okay, so lead sheet cables used in the wire in the cold areas. Okay, so where the snowfall is there, then we are using the lead sheet that one. Okay, and these cables are around the 250 to 400 volts sheeted with the VIR insulation. Okay, so our conductor with the continuous sheet of lead. Okay, for earthing lead sheeted, a separate wire is included. Okay, so for earthing we are using a separate for leakage cut. Next we are having the weatherproof cable. Okay, so next we'll talk about the weatherproof. So in the these cables are employed within the cable required the expose of weather. Okay, so it will not export the weather services. Okay, so these cable either in the PVC or VIR insulation. Okay, so either in PVC or VIR insulation. So conductor being suitable by braided with the compound with the weatherproof material. Okay, so we will combine with the weatherproof material along with the insulation of a PVC and VIR insulation. Okay, so these cable not affected. Okay, so which are not affected by the sunlight and rain. So these are mainly used in the service main slice. Okay, so we can use the service main slice. Next we will having the flexible. So these flexible cables are used to connect wires of ceiling rows, lamp holders, socket outlines, fans, lamps, like this. Okay, so flexible wires that is. Okay, so flexible is obtained by using the large number of strands. Okay, so here the large number of strands will be used here. Okay, so these cables are in various sizes according to the current rating. Okay, so if you are using the ceiling rows, is nothing but at the how it will hang ceiling, right? At that time we're having the one connection there, so that is called as the ceiling rows. Lamp holders, which are when the lamp is placed, that is as lamp holders. Okay, socket outlets and fans. So socket outlets nothing but having the 3-pin sockets, 2-pin sockets, right? If they this is the socket. So next we'll hang the according to the construction. So according to the construction that, so cables are classified the belted cable, H type cable, SL type cable, HSL type. Okay, so that is H means designed by the Hochstar. Okay, Hochstarter. So SL type separate lead sheet type cable, HSL. Okay, so combination of H type and SL type. So according to the type of wire used, so here winding. So winding combination single cotton cover and double cotton covered enamel coated. So in the machines we'll have the windings, the armature winding, field windings are there. So for that purpose we are using that single cotton covered, double cotton covered. Okay, so for each winding, okay, so each winding having the wire will have that. Around that we'll have the insulation. So at that time insulation there is a single cotton covered, double cotton covered, okay, enamel coated wires. Next, we'll having the based upon the according to the method of the improving dielectric crystal. Okay, so there's a solid type cable, oil filled type cables. Okay, external oil pressure type cables. Okay, it's gas pressure cable. So these are the that is a dielectric method. So which are methods we are using? Okay, solid type, oil filled, external oil pressure type cable, gas pressure. Okay, so next we'll hang the high tension belted. So they consist of the voltage up to the 11 kV. Okay, it's consist of a group of circular cords made of the tinned standard copper or aluminum wires. Okay, scores are separated impregnate paper insulation. So another layer of impregnate paper called belt paper is around the insulated copper. Okay, so we can see. So here is the HT type. Okay. So here conductors are there. Okay, so so group of conductors are there, and each conductor having the insulation. Around that we're having the separate insulation is there. Okay, so here's the filler material insulation for each core and belt insulation around that the three conductors and lead sheet around that. Here we can see bedding. This is called as a bedding around the lead sheet and steel copper. Okay, so for armoring. So it's called as a wire armoring. Okay, so for this will be used for this armoring for the mechanical protection. So whenever the mechanically any external force are applied, then we have to protect the conductor. Okay, that is the steel tape. Okay, so and another is the overall survey. So at the last where will be rubber sheath material vehicle. Okay, so for external protection purpose. So here we can see the H type. Okay, so H type cable. So surveying metallic string, belt conductor, and arming lead sheath. Okay, so here the cable has no insulated cable. Okay, the cable has no insulated belt. Okay, so the cable further provided the lead sheath, bedding, armoring, and serving. Okay, so we can see here we have the bedding, armoring, serving, and lead sheath and conducting belt. Okay, so paper insulation, metallic steel. So if you take here, so this line is some different. Okay, so line this steel wiring armoring set. Okay, at the time we are having the different. Okay, so it this H type separator lead type. Okay, so these are the same all are the applications there. So which are the so how it is placed. Okay, so based upon insulation you can observe by the diagrams. Okay, all are the common, but based upon the construction each one is the unique. So you can go through that. So next you can talk about the standard wire gauge. Okay, so to measure the wire, okay, so we have some unit, right? So that is called as a standard wire gauge. Okay, so in the if you are going to the any shop and ask the, so you have you have to think, so which type of the material, which type of wire you want. Okay, at that time, so we have to using the, that is the based upon the standard wire gauge. So used to determine the size of the material wire in terms of the gauge number. Okay, here is the, this is the standard wire gauge number. Okay, so it will having the based upon size. So you can ask, so how much strands will have. Okay, so how much it will having the area. Okay, so how much diameter. Okay, so based on that can the standard, so it can the SWG. Okay, so 20 SW, 0 SWG, 1 WG. Okay, 32 SW. Okay, based on that the conductor size will be dependent here. So user determine the size, SWG, okay, standard wire gauge used for determine the size of the wire in terms of the gauge number. Okay, so insert the wire conductor slot. So here we have to place the slot. Okay, these are slot. So we have to place the wire, and so just being the damage. Okay, so without being damage we have to place, and we have to slot the number is case the number. Okay, which I place that how much number is there. So cable specification. So cable specification based upon the type of conductor. So number of holes, voltage reading, type of insulation, current carrying capacity. So these are the current carrying capacity. Okay, so copper conductors. Okay, so if wanted to purchase any wire, okay, so we have to ask this one. Okay, so number of diameter. So 1 by 1.2, 3 by 0.76. Okay, 7 by 1 point. Okay, so number and diameter of the wire in mm. Okay, so it's a number and subject of the equivalent SW. Okay, that will be by 1 by 18, 3 by 22, 7 by 22, 7 by 20. So if wanted to go the purchase the wire, so we have to use this one. Okay, 1 by 18, 7 by 27 by 22. That is the size. Okay, size, number and size of the equivalent SW. Okay, so here is the nominal cross sectional area. Okay, in case if take the uh, millimeter square. Okay, 6 millimeter square. Okay, then we have the 7 by 18. Okay, so the single core cable is having the 36. Okay, so current rating. Okay, so if 3 or 4 cable, it will stand the 20. 29 amperes. Okay, so how much ampere? Okay, if wanted to use, okay, 5 amperes rating, so we have to use in the 1 mm square. Okay, if wanted to do 10 amperes of rating per single core cable, that is only 1.5 mm square cable you have to use. Okay, 2 mm square cable if there, so it will stand 17 amperes. Okay, so here is the current rating. Here is the ms square. So mail we can ask the we can ask the SWG or we can ask the ms square. Okay. So mainly in the practically, so we'll ask the 1 mm square, 1.5 mm square, 2 ms square, 3.3 ms square, 4.5 ms square. Okay. So generally for domestic there is the 1 ms square and 1.5 ms square. Okay. So for equipment, so application based, we are going for the 2 ms square or 4.5 ms square there. Okay. So here for aluminum wire, this is the classification. So here, what is the purpose of earthing? Okay, that we already tell that. So if if the electrical cooker is no connection is there, okay, so live at neutral wire, okay, so if there, so one of that, okay, so if human is body there, okay, so if operating the equipment, what happens, some leakage current flows through this board, okay, so when man touches there, we will get the shock, okay, so for that purpose we need the earth protection, okay, we have to place that well goes to the earthing, okay, so current takes the at least resistance of that, okay, so man safe and mission will be safe, okay, electricity takes the least path of the resistance, so that will current flows to the only lower resistance, okay, and earth resistance value have the endless, okay, so earth pit depends on the solely soil resistive at the time of the location, okay, so it will depend on the soil resistivity, okay, so it is the resistance of the soil passage electrical current varies soil temperature, okay, so what we'll do, so whatever the leakage current is there, so we are going to give that in the earth pits, so in the earth pit, in that earth will leakage current will be flows to that, okay, so this is about the earth, okay, next we'll talk about the earthing type of earth machines, okay, so how we are placing the earthing, so pipe earthing, plate earthing, okay, that is another part, okay, so today class we have discussed the classifications of the cables, okay, and current capacity of the conductors, materials, either aluminum, copper conductors, okay, and cables classifications, and MCB and ELCB, okay, that we have discussed. Thank you.